For our topic, we chose caffeine because it's a commonly consumed product. Caffeine relates to math because its half-life represents an exponential function. Caffeine is a methyl xanthine naturally occurring in some beverages and also used as a pharmacological agent. Okay guys, what are we gonna do?
I have no clue.
We shouldn't have procrastinated on this. This is too much.
This is gonna take us all night.
How are we gonna get through this?
I know exactly what we need.
Coffee! Now that we have a coffee, let's get down to business.
I wonder how long this coffee will last.
Well, this cup holds 8 ounces of coffee.
So if we drink the coffee at 3 p.m., will the coffee still affect us at 9 p.m.?
In an 8-ounce cup of coffee, there is 100 milligrams of caffeine.
According to Dr. Ananya Mandel in caffeine pharmacology, the half-life of caffeine is 6 hours. If we graph the equation, it visualizes a graph of exponential decay.
The caffeine will affect us because after 6 hours, there are 50 milligrams of caffeine, and after 12 hours, there are 25 milligrams of caffeine. Every 6 hours, half the amount of caffeine will be in our bodies. Over time, the effects of caffeine will wear off because our body metabolizes it.
Oh, that makes sense.
But how do we find the formula for caffeine?
The formula is an exponential equation, where n equals the final amount, NO equals the initial amount, T equals time, and R equals rate.
To find a formula, we must first solve for the rate. To do this, we must plug in the amount after each half-life. The first half-life, or 6 hours, had 50 milligrams of caffeine, while the second half-life, or 12 hours, had 25 milligrams of caffeine.
Next, we set the two equations equal to each other and divide on both sides, e to the 6r and 50. This becomes e to the 6r equals 1/2. Don't make the mistake we made earlier of dividing the exponents instead of subtracting. The initial amount may become unreasonable.
Then, we take the natural log, ln, on both sides to cancel out the e and bring the exponent down. Lastly, we divide by 6 to isolate r.
So r equals ln 1/2 over 6, which is approximately negative 0.116.
Okay, but what's the initial amount?
Finding the initial amount is simple. Substitute the rate into the equation from step 1. The 6's cancel out, as well as the ln and e, leaving 50 over 1/2. After dividing, the initial amount equals 100.
So, the formula for the decay of caffeine is 100 e to the power of negative 0.116 times t.
If the caffeine will be half the initial amount by 9 p.m., then shouldn't we just drink more coffee?
No, you can't just do that.
Why?
You could overdose on caffeine.
Yeah, it's really dangerous. According to an article by Mayo Clinic, it outlines the harmful effects of high amounts of caffeine, which include insomnia, migraine, and headaches.
If you look at a graph, the effects of the caffeine will decrease over time. Every time you drink more coffee, the amount of caffeine increases. If you drink too much coffee, however, it will reach an unsafe level.
Okay, I guess I'll just wait to drink more coffee when it's safe. But when will it be safe?
Well, if we plug in a much larger number for time, such as 200, there will only be 9.23 times 10 to the negative 9 milligrams of caffeine left, which is unreasonable as caffeine remains in the body for only 2.58 days.
Now that we know the effects of caffeine and how it affects us, let's start our project.
Oh yeah!
Thank God we're done.
We better get an 8 on this project.